So this is the schematics of the power supplies on the trainer. And so it's got a multi-secondary winding transformer. So it's got two center tap secondaries, and then it's got one untapped secondary. Then this is kind of misleading. It's a bridge rectifier, but notice the difference. What's the difference between this bridge? If we look at the transformer and this transformer right here. See a difference? And this transformer, so this is a bridge rectifier, and it's serving the function of a bridge rectifier. This is a bridge rectifier, but it's not serving as a bridge rectifier. And what I want to bring up is I'm looking at the transformer on this bridge rectifier, and then I'm looking at the transformer, the secondary on this bridge rectifier, and what do you notice is different? Now, one of them center tapped and one of them's not. So a bridge rectifier works off a non-center tap transformer. This is a center tap transformer. So notice over here, they come over here and they establish this right here as ground. Up here, they don't. They establish the center tap as ground. So if we follow this through, this AC up here sees two anodes. This down here sees two cathodes. So what this is, guys, it's using this bridge rectifier as two center tap power supplies. So this right here gives us a negative. This right here, I'm sorry, here comes the AC. This one right here gives us the negative DC. This right here gives us the positive DC. And so the ground or common is not established on the bridge, it's established at the center tap. So this guy right here, can y'all see the cathodes are pointing back toward the transformer? So this is a negative power supply. And here the anodes are pointing back toward the transformer. So this is a positive power supply. So this right here is a center tap power supply. As I find my so this right here is so this is the negative center tap power supply. And this right here is the positive. So what we're doing is we're using a full wave bridge on a center tap transformer, and we're getting both the negative and positive supply off of it. So this is my negative supply, and it comes down. What's this right here? What function is it in the power supply? No. It's a capacitor. What's the function in the capacitor is not rated, contacts are not rated in microfarads. What's the function in the circuit? Huh? Yeah, so this is our filter. Yeah. Because there's two standard symbols for a capacitor, and this is one of them. And it gets people confused in motor control because that's the symbol of a contact. But this is what defines it right here. It's labeled C9, which is a common designator for a capacitor, and the size is given in microfarads, which is what capacitors are given in. So this is a 2,200 microfarad capacitor, and it's rated at what? It says 25 volts. I thought it was 35. These are what we call pre-filters and post-filter filters, and when you look up this regulator, it will let you know that how to size those. This right here, this is the 7900 series 3-terminal regulators. So all the 79s are negative regulators, and the 78s, these are all positive regulators. And these are what we call fixed regulators. So they've got all the electronic circuits inside there to regulate. And this it's real easy. It's 7912. So what they do is the last number identifies what the voltage is regulated. So this is a minus 12 volt regulator, and this is a 7812. So this is a positive 12 volt regulator. And then so this is the filter for this. I just noticed that, guy. Whoever drew the schematic drew it wrong. Can you see what they did right here on this capacitor? Huh?
What they do on the capacitor?
Yeah.
No.
They got the polarity wrong with the capacitor because they identify the positive. So the positive is supposed to be down here because this is the negative regulator, right?
Right.
What's that? Yeah, the 79 and the 7800 series are really neat 3-terminal regulators in that they tell you what they are. So a 7805 would be a what? A 5 volt regulator. These are all 1 amp regulators, by the way, the 7800 series. 7800 series are positive regulators, 7900 series is negative regulators. But these are what we call fixed regulators. So they regulate at a certain voltage. Yeah, this is a negative regulator, so that's a negative voltage right there. And you can see what they said they did. They said they put the positive toward the negative, and we showed that video, right, of them blowing up them capacitors. So that's got to be wrong. So it's just ever drew it, just drew it. So this comes in. This is the light emitting diode, which we'll learn about later on. So this is what comes on when the minus 12 volt supply, I don't know what color it is. And then this is the terminal board right here, where y'all actually connect to the negative 5 volt supply. So that's that terminal that's sticking up in the air right there. And you see this done quite often, by the way. This isn't the first time I've run into that, where they use a bridge rectifier, but they wire it to be a full wave center tap. And of course, here's the positive. There's the filter. Here's the 7812. That's the positive 12 volt regulator. This is the pre-filter and post filters that is in the data sheets. And this gives you plus 12 volts. And this is the light emitting diode that comes on when the 12 volt supply is okay. So if you see a bridge rectifier, but it's used with a center tap transformer, then odds are it's serving as 2 full wave center tap. It's not serving as a bridge rectifier, it's serving as a full wave center tap. Now down here, this is truly a full wave center tap circuit, because notice the transformer's not grounded, so that's a full wave bridge. And then we come over, here's our filter. and it's connected correctly. And then this comes way out here to a fixed regulator, a 7805, but it's not actually a 7805, it's a 78H05. So these are 1 amp regulators. And then this is a 3 amp regulator. And we couldn't find the 78H05s anywhere. So we replaced it with a 74323, which is a 5-volt 3 amp regulator. So when they burn up, this is one of the ones that gets burned up all the time for some reason in DC. I think one of the labs they have to do is with a 5-volt power supply, and they don't use the variable. They hook it up to this power supply, they hook up their circuit wrong, and screw up that regulator. So what goes out, let's see, we lost both of these during class. I'm not going to say who did that. And then we've lost a lot of 5-volt regulators in these classes, and 2 transformers. And about the only place you can buy this transformer is through RS, I can't remember the name of the company that actually makes the trainers. But these power supplies are not complicated to troubleshoot. Normally you can tell right off the bat if one of them's not working because the LED don't come on. This is not in the chapter. This is the schematics on the trainer. So what we're doing is the book talks about power supplies, but this is real life. This is the actual trainer that y'all are working with. This is the schematics of the power supplies on the trainer. So when you go over there and you hook up to that transformer, there's a transformer right there. It's just a center tap transformer. It comes out, it's got 3 terminals, 3 slotted terminals, a little breadboard. Now these are so I take this, so this is positive DC right here, full wave center tap. And then this also comes over here to an LM317. An LM317 is a positive variable regulator. So I think I showed y'all this the other day. It's a 3-terminal regulator, but this goes to a pod that's wired to act like a rheostat. Then this is the so you got three leads. They call them 3 regulators, and they're real easy to work with. So one of them is going to be labeled input. So this is for your unregulated end. One of them is going to be labeled output. So this is your regulated output, and the other one's going to be labeled common. It's not going to be labeled ground. It's labeled common, and that's all it is to hook these things up. They come in a TO222 case, which we'll look at in a minute. Now this one's labeled, this one has N, this is unregulated N, then it has an out, and then this would be regulated out, and then this pin is labeled adjust. And what we do is we take this and hook it to a rheostat, but most of the time it's just a pot wired to act like a rheostat. And then it's got this feedback right here from the output that goes back, and what it's doing is matching the set voltage with the feedback voltage, and I think it's looking for like a 1.25 volt differential. So if the output tries to go up, it lowers it down. If it goes down, it tries to go up, but you got to have that feedback because this is an adjustable regulator, right? So this is an LM317. This is a variable negative plus regulator, This is the LM337. This is a variable negative regulator. You notice the circuits are the same. Except for the polarity of the capacitors. And then I think I just showed y'all the 5-volt regulator, right? This is in a case called the TO3 case. So this is a high current regulator, and that's the power supplies in the trainer. So we have a positive 12-volt regulator, we have a negative fixed 12-volt regulator, we have a variable regulator, a negative regulator, we have a positive regulator, we have a negative variable regulator, and then we have a fixed 5-volt regulator. And then this is the transformer that you are tapping into. Right here is a center tap transformer. This is where you're hooking up your power supply.